So with our enemies now flashing white when we hit them, it's adding that little bit of extra feedback to our player. But at the same time, every time we hit them, we're doing a little bit of damage, but it doesn't actually look like it's kind of changing how they're attacking us. I mean, they're robots, they're not moving particularly fast, so what we could do is add a little bit of pushback whenever they get hit by our bullets. So that's what we're going to do right now. So it's pretty simple. All we're going to do is add a little bit of force whenever our player hits any of our enemies. So if we go to our enemy controller script, we'll let that open up here. There we go. We're basically going to add a little bit of, we're just going to add a function to knock back our enemies whenever they get hit. So we're going to add this function into this script, but our enemies getting hit is actually controlled by our bullet controller. If we go to our bullet controller over here, we see that whenever we hit an enemy, we're setting the enemy health manager to take some damage. So we're taking damage in the enemy health manager. So if we go back into our enemy health manager, we see it here. So we're going to call it from here whenever we take some damage, because just say for example we have something set up where our enemies only take damage in certain situations, not necessarily whenever they get hit by a bullet, because who knows what way you want to do things within your game. So we're going to make sure that it's only when we're actually taking some damage that we want to call it in here. So our enemy controller here, we're going to add a function in here that we'll call then from our enemy health manager script. So we're just going to create a function here first of all. We're going to call it our public void knock back, like that, and we'll open and close our little curly brackets. So if we're going to add some knockback to our player, there's a couple of things that we're going to need to know. We're going to need to know how much force we're going to knock back our enemies with, and we're also going to need to know how long our knockback should last for. So we're going to add a couple of references up here. So like I said, we're going to need to know how much force we're going to have. So we'll create a public float that we'll call our knockback force. We need to know how long it's going to last. So that'll be a public float knockback length. And again, whenever we create a timer, we need to have not a public float, but a private float to use as a counter. So we'll use that. We'll call this our knockback counter. And then finally, because of the nature of knockback, what we want to make sure is that our robot isn't also moving forward at the same time as we're knocking it back. So we're going to create a bool, a private bool that we'll just call knockback. And basically, whenever this is true, then we won't let our player be able to move at the same time. Okay, so we have our knockback down here, our little knockback function. So basically what we want to say is, okay, we're calling this function, what do we want to happen? Well, first thing we want to do is say our knockback counter should be equal to our knockback length, so that we can start ticking that down and making that have an effect, or knowing how long we want our effect to last for. Sorry. The next thing we want to do is say, okay, set the force of velocity that we're having. So on the rigid body, my rigid body, the velocity, we want to set that to be a new vector 2, because instead of just the force that is moving our object to the side, which is what we're doing up here, or moving our enemy to the side, we want to say and knock that back the opposite of the way it's coming. So how do we know which way to knock it back? Well, basically we know if our enemies are facing if the transform local scale of our enemies is at 1, we know that they're moving to the left, and so therefore we want to knock them back to the right, because our player is should be shooting towards where the robots are facing. So what we want to say is equally before we start typing stuff, what we want to also say is if our robot is facing to the right, then his local scale is now -1. So what we can do is to knock them then back to the left, we can just multiply our local scale of our robot by whatever force we wanted to have. So then we were able to knock our robot either left or right, depending on which way the robot is facing, basically. So what we can say here is, okay, our knockback force on the x-axis should be multiplied by our transform dot local scale dot x. So that'll be our x value, so that'll either be a 1 or a -1, depending on which way our robot is facing. And then for the y velocity, we could just leave that to be whatever velocity the robot has, so that he only gets knocked back along the x-axis. But just for adding a little bit more interest to it, we'll just set that to be our knockback force. So he also gets knocked a little bit up into the air at the same time as getting knocked back. Okay, so the next thing we want to do is, now that we have our knockback being activated, we want to set our knockback bool to be equal to true. So now that we know that's true, we can do some stuff up here in our update loop. So what we can do here is just add a new check. So we can say if our knockback is activated, we can do some stuff within here. So if our knockback is currently activated, then we know we needed to count down. So we can say our knockback counter should be minus equals time dot delta time. So it will tick down as each frame goes along. And as long as our knockback is counting down, we need to be applying that force that is knocking the player, or knocking the enemy back. So we'll do the exact same thing as we have down here. We'll keep applying our knockback force. But when we knock our enemy backwards, we only want to knock it upwards once. We don't want to keep pushing it up into the sky the whole time. So what we're going to do is, instead of using a knockback force to keep pushing it upwards, now we're going to say keep using the myRigidBody dot velocity dot y. So that way it'll smoothly go up in the air and then come back down, rather than just steadily moving upwards, which would look a little bit awkward. Okay, so we've got that in action there now. The next thing we want to do is check and see if our knockback should be changed back to being false if our counter goes below 0. So we'll say if our knockback counter is less than or equal to 0, well, if that's the case, then what we want to do is say our knockback is equal to false. So that's all fine. That's basically our knockback function working perfectly fine. But at the moment, what will happen in every update loop is, so our knockback, it'll push our enemy back a little bit, it'll count down, and say if our knockback counter is above 0, well, the next thing that'll happen is it'll go out of this loop, and then it'll continue on doing the normal movement that moves our enemy around in the world. So we don't want it to do that. So what we can do right here is just type return, like that. So what return will do is it will end our whole loop here. It'll just say, okay, stop going through the update loop. We just want to we want to kind of break out of this, and we won't actually do any of this stuff down here. So that way it'll keep just knocking our player back the way we wanted to, or knocking our enemy back the way we wanted to, and it won't actually start trying to move it the normal way it is moving in the world. Okay, so we'll let this go back into the game and let it compile, and then we're going to change the values that are affecting our knockback within the world. Where's our enemy controller? There we go. So our knockback force, let's just set this to be about 5, and the length of knockback, we'll set it to happen for just a quarter of a second. Now obviously we of course need to actually call this knockback to make it happen within the game. So if we go to our enemy health script, we want to call it here. So if we're going to call it on our enemy controller, we'll need a reference to that. So we're going to set up here, we're going to set a private enemy controller that we'll call the EC, and then in our start function we're going to make sure that it automatically finds the enemy controller script is attached to the same object as our enemy health script. So we'll say the EC is equal to get component enemy controller, and it'll set it to be that. So then down here, when we take our damage, we can say, okay, on the enemy controller, run the knockback function. So we'll say the EC.knockback, and we have our little brackets and our semicolon, and I will save this, and we'll go back in and let that compile again. We'll make sure we apply these values, or we'll apply these changes that we just made to our robot down here. We'll apply them to all the prefabs like that, and now we'll hit play, and you can see our robots kind of get knocked back and up into the air. So maybe our little knockback force might be a little bit too strong. Let's pull that down to 2, so we don't want to completely stop them. There we go. We see they get knocked back just that little bit, and it makes that little bit more interesting. Just to see it that little bit better, let's just go down and give them a little bit more health. So we'll put them up to 5 health. We'll hit play again. So there we go. We can see they're getting knocked back by our bullets. Okay, we got killed a little bit there, but as you can see, they're getting knocked back and actually looking like they're taking some damage. I feel like our flash might be lasting that little bit too long, so I might actually shorten that back down on our robot. If we just go to our enemy health, put the flash length back down to 0.1. Play this again. There we go. They look like they're flashing a bit better now. So yeah, there's too many robots for us to be able to handle at that health level. But you can see we're actually looking like we're doing that little bit more damage to them. And again, it just makes it a tiny bit more interesting for when we actually hurt our enemies.